And in here we would like to look at the simplest case of the previous video we had a motivation for numerical interpolation, and in this video we would like to look at the simplest form of numerical interpolation, i.e. linear interpolation. So we said last time that if we are given two sets of values, i.e. these pivotal values, just two sets, okay, i.e. if we have the set x0, y0, and we have the other x1, y1, we can approximate, okay, we can find the value of the function, or we can find the value of the function at any intermediate point here using a polynomial of degree at most 1. Okay, that is, we have two sets of points, therefore we say that the approximating polynomial degree will be less than or equal to 1, in this case, which is simply 1. Okay, so now that we are going to approximate these two sets of values using a polynomial of degree 1, which is simply a straight line, i.e. the word linear interpolation, we shall make use of a very simple concept of the gradient. So here we have the point x0, okay, y0, and then here okay, this is now the point x1, y1, okay, and then let's say we have any intermediate point x on y. Please bear in mind that y is equals to f of x in case I use any of these interchangeably. So since this is a straight line, we can say that we can compute the gradient by taking the change in the y divide by the change in the x, okay, and this should be equal to, for the same gradient, it should be the same for any other point on the line as well. So if I can now take the gradient here between these 2 points, then we can say that this is going to be the change in the y, okay, divided by the change in the x. So the gradient here is the same, and then we can equate these and then say this divided by x minus x0 should be equal to y1 minus y0 divided by x1 minus x0, for which we should make y the subject and be able to get that y equals to y0 plus x minus x0 divided by x1 minus x0 multiplied by y1 minus y0. Okay, so for equidistant points, okay, we are going to say that x1 minus x0, we simply set it to h, the step length, okay, and yeah, so that now we can write y equals to y0 plus x minus x0 divided by h times y1 minus y0. So we can further write this and then say this is y equals to y0 plus r, where r is x minus x0 divided by h. This is what we are setting to be our r. And then we know by now y1 minus y0 is simply the fast forward difference evaluated at x0, which is denoted the fast forward difference y0 here. Okay, so this is the formula that we are going to use if we want to determine the value of a function at an intermediate point given two sets of pivotal values. So let us look at a simple example here. So in the example, we would like to evaluate the natural log of 9.2, okay. However, we know all the information, all the data we already have is that the natural log of 2.0, of 9.0 is 2.197, and we also know that the natural log of 9.5, okay, the observed values, our data set that we have, is 2.251. Okay, so now I would like to start with drawing a table, though it may not be necessary. You can do this without this table. However, since in the next in the next video we shall be talking about quadratic interpolation, where we will definitely need a table of similar sort. I will just use a simple table for this one here. So in the table we have our values of x, and then we have our y equals to f of x, and then we have our fast forward difference here. So I hope you have been able to see that this is our intermediate point x, okay, because we have a point to the left of it, which is our x naught, and then we have a point on the right of it, which is our what, x1. So here when we are filling in our x naught, what is our x naught? Our x naught is 9.0. Then we have the value of x, which we want to find, and then we have our okay, we shall leave it at that. Okay, this is 9.2 actually, okay, and then this is our 9.5, i.e. this is our x naught, this is our x1, no, this is our x naught, and then this is our x1, and then this is our intermediate value. I'm just writing this because I'm explaining, but you don't need to put it there. All you need to know is these values here. So natural log of 9.0 is 2.197, and then this one here is 2.251, and then the fast forward difference here, this is the fast forward difference here, we know it is y1 minus y0. Again, this you should have at the back of your mind, you don't need to fill it in here. However, we know that this is y1 minus that, which is 2.251 minus 2.197, okay,